Hey there, my name is Max Inman with the Solidworks training team, and I'll be walking through a fun, engaging design project using SolidWorks X Design where we make a fantastic flying glider. Throughout human history, we've been fascinated with flight. In ancient China, kites were invented around 500 BCE, with the largest being able to lift a person into the air. This fascination with flying has taken many forms through the years, from Leonardo da Vinci's winged sketches to hot air balloons, flying zeppelins, early planes, and today's modern aircraft. In this design project, we tap into this fascinating concept by making our very own fantastic flying glider. In this project, we'll explore the design intent behind the flying glider by considering functional criteria, examining material choice and its impact, investigating the flying glider through a design overview, outlining the laser cutting and assembly process, and finally, reflecting on our design through a design review. Our goal for this project is to create a flying glider that flies smoothly through the air. To do this, we'll create 5 components to design, laser cut, and assemble. A large wing that allows for smooth flight, a rear stabilizer to control the glider's descent, a strong fuselage to hold all the components together, and 2 different ballast pieces to control the glider's center of mass. One critical design limitation arises from our use of a laser cutter. All components must be 2-dimensional and share a uniform thickness, as the entire glider will be cut from a single sheet of material. To ensure stable flight and prevent it from falling to the left or right, the parts will be designed to be symmetrical about the glider's center line. The center of mass of the glider is important to keep in a specific location, about 1/4 of the way down the chord or length of the wing. This will improve the stability of the glider as it flies. The angle of the wing is also very important, and is controlled by its cutout in the fuselage. If we tilt the wing too far back, the plane can stall, but if we don't tilt it enough, it won't generate any lift and fall to the ground. A wing angle of around 5 to 10 degrees is recommended, but depends on your specific material choice and desired flying style as well. There are a lot of different materials you could use to make this glider. However, we do have some criteria for this project to narrow down our material choice. We want this material to be strong, light, and thin, and come in a large enough sheet of material to make the glider out of only one sheet. Some great choices for material include balsa wood, foam board, and sturdy cardboard. For this project, a material thickness between 1/16 and 1/8 of an inch, or approximately 1.5 to 3 millimeters, is ideal. Make sure to accurately measure your material thickness. Using a pair of calipers and taking multiple measurements at different points, then calculating the average, is a good start in determining an accurate thickness value. The design of each of the flying glider's components are simple. We start the wing by sketching half of the profile, and then use the mirror tool to complete it. This ensures symmetry as outlined in our design intent. We'll try to use the mirror tools as much as we can throughout this project. We'll then fully dimension the profile and extrude it by the measured material thickness value, and then add fillets. The stabilizer is built similarly to the wing. Sketch half of it, mirror it, fully dimension it, add sketch fillets, and then extrude our measured material thickness value. Adding the fillets in the sketch, like we did here, is another valid way to create the rounded corners of the model. The fuselage is made in 4 steps. First, we create the outer profile of the sketch, and then extrude it our measured material thickness. Then, we cut out 2 slots, one for the wing, and then one for the stabilizer. Finally, we add fillets to round the sharp corners of the model. There are 2 different ballast models to make. They fit on the front of the fuselage, with one fitting centered on the other. These are made with the sketch, again using the mirror tool. Then, the sketch is extruded by our measured material thickness value. Creating an assembly will allow us to visualize our final product before we go through the effort of laser cutting and assembling it. It also allows us to visualize the center of mass, a key value in considering how well our glider will fly. Now, let's laser cut and assemble our very own flying glider. From XDesign, we export the faces we want to cut as DXF drawing files. Once imported into your laser cutter software, adjust settings to correctly cut your material. Always follow your lab's safety guidelines and the machine's best practices. To save material, nest your parts together with around a 1/16 of an inch spacing between them. Once everything's cut, assembling the glider is easy with a little help from some super glue to keep it together. The project design review is the time to reflect and investigate the challenges and successes of the glider, empowering curiosity through the lens of STEM. This project is a great opportunity to use CAD in an interesting, engaging project curriculum. A flying glider can be used to investigate flight from the perspective of physics, serve as an introduction to the engineering design cycle, foster collaboration through competitive design, and much more. Thank you for watching, and if you found this video helpful, click the link in the description below to access more great content.